let's get going. Okay, so we are going to talk about drawing these for covalent bonds. I will, bossy. Covalent bonds. So what is a covalent bond?
So it's
Non-metal, non-metal. What do they do with their electrons? They share them, either equally or
Not equally.
unequally.
Not equally is
That's ionic. Okay, so I'm going to be, if you are in homeroom and you're under my notes, this is an added slide that I just added in there, so you might want to take a picture of it. The way to do that, I've called it the alternate method. This is a new method, the way I'm teaching it, and I think I like it a lot better than the old way I've been teaching it. So the very first thing we need to do is you need to just write in your notes somewhere that every atom wants to have how many electrons in its outer shell? 8. There are 3 exceptions. You need to memorize those exceptions. The exception is that hydrogen wants to have 2. 2 valence electrons. Boron wants to have 6 valence electrons. Boron,
You have
B.
to memorize those.
Yes. Beryllium wants 4. 6. So if I look at the periodic table, I see hydrogen, and then next is beryllium, and then next is boron, and I just go 2, 4, 6. They just double. Everybody else wants to have 8. Okay, so we're going to start. I'm going to give us a compound. Our compounds that we are going to do our example with is going to be carbon tetrachloride. Okay? CCl4. That's what we're going to do to draw. Needed. How many electrons, valence electrons, does each one need to be happy? 8. There's no exceptions in there. How many atoms do we have total in this compound? 5. 8 times 5 is how many? 40. We need 40 electrons for this molecule to be happy. But what is available? So I need to go see and look at the valence electrons for each atom. How many valence electrons does carbon have? 4. How many does chlorine have? 7. How many chlorine atoms do we have? 4. So 7 times 4 is 28. Plus the 4 from carbon, 32. So what is available is only 32 electrons. I want to have 40, but I don't have 40. I only have 32. So that means we're going to have to share some. So now we're going to see how many of these electrons are going to be shared. So we're going to subtract 40 from 32 from 40. 8. When I'm sharing, it's between 2 atoms. So we're going to divide it by 2. And that gives me 4. That number 4 represents the number of bonds in this atom or in the molecule. It's always divided by 2 because we're sharing between 2 atoms.
So if you have more than one atom, would you write them off?
You always divide it by 2. It doesn't matter how many atoms are there. It's always divided by 2. Okay. Now we're going to set the structure up. So the skeletal structure, to set it up, the least electronegative one goes in the middle. That means the one that's furthest away from fluorine is going to go in the middle. And then there are 2 rules. Hydrogen can never be in the middle. Why?
Because it's only happy with 2.
It's only happy with 2. It can't bond. It can only make one bond. And carbon, who loves attention, will always be in the middle if it's there. Okay? So how are we going to set the skeleton up? Who's in the middle? Carbon. So I am going to put carbon. If I make this a little bit bigger, maybe you guys can see it. I'm going to put carbon in the middle. And then I'm going to surround it with how many chlorines? Chlorine, 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 chlorine. That is what we call the skeletal structure. Now we need to make our bonds. How many bonds do we have? 4. And a bond, so we're going to draw a line, and that represents a bond. That is 2 electrons. That's an electron from chlorine and an electron from carbon, and both of those are being shared. So we need to make our bonds 4 bonds. So now that we have our 4 bonds there, we need to finish out the octets around these outer atoms. Okay? So we have how many? We need to have 32 electrons. We have 2, 4, 6, 8, 9, 10, 11, 12, 13, 14. That chlorine's happy. 15, 16, 17, 18, 19, 20. That chlorine's happy. 21, 22, 23, 24, 25, 26. That chlorine's happy. 27, 28, 29, 30, 31, 32. Did we use up all 32 that we had available? Yes. If there are any extra, they go on the central atom. But we didn't have any extra. So now you go, wait, but there's 6. 1, 2, 3, 4, 5, 6, 7, 8. So chlorine's 8 are right here. This chlorine has 8. This chlorine has 8. This chlorine has 8. And carbon has 8.
So the line means 8.
And a line means 2 electrons. Available, so or needed. How many? Everybody wants to have how many? 8. And how many atoms do we have in this case?
Oh.
Okay. Ready to try another one? Again, there's an alternate method. This is how I used to teach it. I really don't like it, especially when it comes to double and triple bonds. You do need to know that we can have double and triple bonds. So a single bond is just one line. It represents 2 electrons. We can have a double bond. It's 2 lines. It represents 4 electrons being shared. And then you have a triple bond. 3 lines that represent 6 electrons being shared. And then we have something called a lone pair. Those are my extra electrons that don't hook up with something. Okay, so those are unbonded electrons. And those are going to be very important to us next week. What? All right. Let's do one. N2. Nitrogen. Nitrogen. How many does nitrogen need to be happy? Every atom wants to have how many? 8. So nitrogen wants to have 8. How many nitrogens do we have? 2. 8 times 2 is 16. We need a total of 16 electrons for everybody to be happy. What is available to us? Let's go and look at the valence electrons for nitrogen. Nitrogen has how many valence electrons? 5, and we have 2 nitrogens. So a total of 10 electrons are available. Now we have to share some. So what is left over? 6. Always divided by 2 leaves me with 3. So how many bonds is this molecule going to have? 3. All right, so we don't have a central atom. We have N and N. So we have to bond them. 1, 2, 3. How many electrons of our available 10 have we used? 6. Does anybody have 8 around them and happy? No. 6, 7, 8. So now this nitrogen is happy. 9, 10. We used all of our electrons, and now this nitrogen is happy. Huh? The least electronegative one, so the one that's furthest away from fluorine. Let's do one more. Always divided by 2. Let's do water. Yes.
I thought you needed 16 electrons. Isn't the needed 16?
Needed is 16. I don't have 16 though. So we need 16. We don't have 16 available, so that means we're going to have to share.
On the last one, do we have 16? Oh, so technically those bars are like 4.
This is 2, 4, 6. We're sharing 6 electrons right there. Okay? All right, let's do water. H2O. How many are needed to make this happy? Is one of our ones in the next?
10. 10.
Okay, so but each hydrogen wants 2.
Oh, so 12.
12. How did you do that?
Because oxygen needs 8 and then hydrogen only needs 2 for each.
Oxygen, thank you. Oxygen needs 8, and hydrogen is an exception and only wants 2. And there's 2 of them. How many are available? How many valence electrons for oxygen? 6. How many for each hydrogen? 1. So total of, so how many are being shared? 4 divided by gives me 2 bonds. Who's in the middle? Oxygen. Hydrogen can never be in the middle. All right. Now we do our bonds. We have 1 bond, 2 bond. So we've used how many of our electrons? 4. We still have 4 more to go. Can I put them on my H? No, we can't put them on the H. So where do they go? Any leftover ones always go on the center.
Wait, where'd the rest of the 4 go?
So, one, like, the line.
Line is 2 electrons. 2 lines is 4 electrons. 3 lines is 6. Okay?
So with the exception of hydrogen, if it's on something else, that one again, this is because oxygen is closer to.
All right, we're going to do one here in a minute. All right, everybody good? We're going to do some more. We're going to practice. I want to do CO2. Carbon. So we have needed, available, and shared. How many is needed in this molecule? 24. None of them are special ones, and we have, so each one of those atoms wants 8. So 8 times 3 atoms.
Oh, okay.
How many is available?
How'd you get 24?
24. Each one of them wants to have 8, and there's 3 of them.
Yeah,
18. So 18 are available, which means that we are going to share. No, the math is wrong somewhere. Oxygen is 6, and 6 is 12, plus the 4, 16. So we have 8 being shared. 8 divided by 2 gives me 4 bonds. All right, so let's set the skeleton up. Who's in the middle? Carbon. Carbon's further away from oxygen. And I will tell you a trick. Usually when you see them like this, Cl2, then if there's more than one of them, it's probably not in the middle. Okay? So we have C, and we have O, and O. We have 2 atoms on either side, but we need to make 4 bonds. So, 1, 2, 3, 4. How many electrons have we used? We need to finish out the octet around those. So 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oxygen has its 8, carbon has its 8, and the other oxygen has its 8. Huh? It's the least electronegative, which means it's further away from carbon than oxygen is. Or fluorine, sorry. Furthest away, the further you get from fluorine. And usually when you have more than one atom, that one's not going to be in the middle. Okay. Let's do one more. Let's do Br2. How many are needed? How many are needed? How many are needed? Everyone wants to have how many? 8. And there are 2 atoms. 16. How many are available? 14. That difference is 2. Divided by 2 gives me 1. Shared. So 1 is bond. So we're just going to go ahead and put bromine and bromine. Thank you, Ty. We put our 1 bond. That's how many electrons? 2, and we need to use up 12 more. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And now everybody's happy. Everybody good? Okay, we're going to do one more because I'm going to throw you a curveball. Let's do SO3. SO3. So SO3. Yep, give me 1 second. So we have needed, available, shared. Needed is 32. Available is 24. That means how many are being shared? 8 divided by 2 is 4 bonds. So we're going to set this up. S is in the middle. Oxygen on either sides. 3 oxygens. I have 3 atoms, but how many bonds do I have? 4. One's double. Which one does it go on? It doesn't matter. Now we're going to finish out the octet. So we have 2, 4, 6. So 2, 4, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24.
Wait, you
25. Oh, yes, I did. It's wrong. Why is this wrong?
because the 2 bonds make
The 2 bonds make 4. So I've added too many electrons over here, which means I need to put them over there. That was a curveball for me. Okay, so what you need to know is this, that double bond, it doesn't matter where it goes because it's shifting. It's going to each one of those O's. It's not staying put in that one spot.
So how is it going to go to each one if that one already has
This one will flip over here and these electrons flip over there. So they're just shifting those electrons back and forth. Yes?
For the S, like whatever number you get, that's how many lines there
Huh?
are. Like how many lines there are for S.
Yes.
Okay.
Are there any questions? So let's do one more. It's on your homework, so. We're going to do NH3.
Here you go.
Needed, available, shared. How many is needed?
14.
6 and 8 is 14. Why is it 14 and not 32?
Because hydrogen needs two.
Hydrogen only needs 2.
Oh, yeah, okay.
How many are available?
So would hydrogen be 1 then?
8. So how many are shared? Divided by 2. 3 bonds. Who's in the middle? Hydrogen on either side. And then we're going to get our bonds. 2, 4, 6. I have 2 electrons left. Where do they go? In the middle, on the central atom.
Dang.
Alright, keep it so thick.
Any questions? So your yes.
No carbon, no hydrogen.
Uh-huh.
How should we tell which one?
Okay, so how I tell is if there's more than one of these atoms, it's probably not in the middle.
Probably.
Most likely it's not in the middle.
Most likely.
9 times out of 10.
Sometimes. Man.
Do you?
What's that exception, carbon?
I mean, carbon's always in the middle.
If carbon's there.
It's just
If carbon's there, it's going to be in the
Will
middle.
there be
What if there's, like-
one problem with multiple?
What if there's like
Right. Okay. Let's do this real quick. Okay, hold on. Let me stop my recording and I'll do one on the board.